Hello everybody, welcome back. This is the final video of our Chapter 6. This is 6.6, Example 2. It's the last page of your booklet. And what we're going to do is we're going to be looking at this word problem. And this word problem has to do with construction. And we're looking at narrow and wide boards for construction fees. So L&G Construction is competing for a contract to build a fence. The fence will be no longer than 50 yards. And will consist of narrow boards that are 6 inches wide and wider boards that are 8 inches wide. There must be no fewer than 100 wide boards and no more than 80 narrow boards. The narrow boards cost $356 each, and the wide boards cost $436 each. State the variables in the domain. So the first thing I look at, I see that we have yards and inches. So you may remember from Math 10 last year. In the first chapter you did conversion, so that's what we're going to do now. We're going to convert that yards to inches, so we know how many inches we need. So we have X inches is equal to 50 yards. Yards, and we know that there's 36 inches in 1 yard, and if you don't remember that, that's fine. I will give you that information. In 1 yard. So essentially what you do is you multiply 36 by 50, then you get 1,800 inches. So that's how much, how long the fence is. So that'll give you an idea how many boards you're going to need, right? So that's important to convert that right away. We're going to state the variables. All right. So the narrow boards come first. So again, it doesn't matter the order in which you do that, but I'm going to say let X equal the narrow boards, the number of narrow boards. You can just say narrow, but I'm just letting you know exactly what it means. And let Y equal the number of wide boards. Okay? And remember domain range, right? These are the restrictions. So the number of boards we need, narrow boards, that's going to be X is now in the real numbers. X. Or sorry, whole numbers, my bad, because you got to buy the boards in full. Y, number whole. Okay, so it's just number of boards are both going to be whole number. Let's look at the constraints. So the constraints are, let's look at first. It says that there's no fewer than 100 wide boards. So we need at least 100 wide boards. Y greater than or equal to 100, at least 100 wide. And the second constraint there is going to be narrow. Narrow is X, and it says no more than. We don't want any more than 80 narrow. So X must be less than or equal to 80. No more than 80. All right. And so to get the total distance with respect to the 1,800 inches, that means if it says the narrow boards are 6 inches, so it's going to be 6x. It's going to be 6x. And 8 for the y, so 8y. And if we want the fence to be 1,800, so it's going to be no longer than that, right? So it's going to be less than or equal to 1800. So there are your three constraints, or your three linear inequalities. The objective function comes from the cost. So we'll use C for cost. So cost is going to equal $3.56 X, because that's the narrow, plus $4.36 for the Y, and Y is Y. So there's your objective function. And we're going to graph the inequalities. That's on the graph here. So our graph is going up by, the graph's going to go up by, if you look at, the Y's are going up, it's 100, these are 80. So we'll go up by 25s here, because 25, 100 to multiple 25, and the y-intercept is 225. So that'll go right on the graph. And then these, the x value is 80, so we'll go by 20s. And you can do that on the graph, right? So I've gone up by 20s, 20, 40, 60, 80, and 25, and so on. So I've got my first line at x less than or equal to 80. So we're going to shade to the left here. All right. I'll leave that alone because we're going to do the integer or the whole number values. I'll put my line in 100. And remember, it's all the values above. So you're going to shade above and to the right here. And then I'll draw my inequality line for the y less than or equal to negative 3/4 x plus 225. And there we have it. And it's less than, so it's going to be here. So what it essentially does is it shades in this region here. And then what we'll do is we'll add in the integer values. And we'll put all those integers and we'll draw all those in. Okay? And there they are, all the integer values. All right? Remember, we're really only interested in the vertices now anyway. This is like the old shading, but what we're really interested in is the vertices of the polygon, that is the feasible region of the curves. Okay? So that's what we're interested in here. So we'll graph our inequalities. We just did that. And make that a little smaller for you. So you can have a spot for your values there. So put our graph right there. Okay? And label your graph, of course. Narrow boards on the bottom. I don't have room for that, so you folks can do that. So I put 4 locations here for the maximum and minimum because there are 4 vertices, right? So I've entered in my 4 vertices, 0 and 225. Obviously, you know that as if you have 0 and 225 and then 0 and 100, you know that obviously this one is going to be more than this one, right? But we're still going to calculate it for now. Again, once you get the hang of this, you're good to go. All right? And put the cost in at 0 and 225. So that means we have 0 narrow boards and all wide boards. All right. So we'll enter those in. So it'll be 0 plus 981. So the cost is equal to, we'll put a dollar sign in when we're done, $981. So that means if we use 0 narrow boards and 225 wide boards, that'll yield a cost of $981. Okay. So essentially, you can do that all for the 0, 100. I'm just going to steal all that for a second. I'm going to put 100 in. And put 100 here, which would be 436, which would be $436. Okay? But again, obviously this is going to be a much smaller fence, right? You're only using 100 boards, but it still satisfies the rest of the inequalities that were mentioned. Oh. This one is 80 and 165. So we're going to calculate that. So 80 multiplied by 356 is $284.80. Oh. And $4.36 multiplied by 165 is equal to 7.19.40, which would equal a total cost of $1,004.20. And we do the same thing, only with the 100. All right, this would be 100, which would make that 460 or 436, which would add it up to 720.80. So the maximum cost would be $1,004.20 based on all of the restrictions and the constraints given in the inequalities. Okay? So that's it. The final questions for the 6.6 is page 341, numbers 1, 4, 6, 9, 11 through 13. So I hope that helped as we work through the questions. Again, we're going to do them in class, but if you're not here, these are great resources to help you. Hope you're enjoying the videos, and that's it for Chapter 6. Thanks, folks, and we'll see you in Chapter 7, Quadratics.